Lift drawings for field engineers, how to review lift drawings in construction. Okay, so I'm really excited about this. In this video, I'm going to talk to you all about lift drawings, where our industry is headed or should be headed, and how you can leverage this skill to benefit your career. I want to say something as I start out, and I want to work from the end in mind. If you are out in the field and somebody wants to, I'll just do another because I did so well with it just in the previous video, because this is a series of 20 videos about field engineering, which will become a book. If you're out there and you're wanting to build this wall, and the footing is here basically for reference, so I did okay on the isometric. You want to build this footing. Think about what you would have to do or know to build this wall on top of this footing. Well, first of all, you'd have to have layout and control. The other thing is you would have to have the information for this. I'm just going to call this a lift drawing, okay? With those key things, you can go build that wall as long as you have the humans, the tools, the materials, and the equipment, and maybe other resources. And so when we think about what a field engineer does, I like to anchor back to, and I can link this to you in the description below, but there's at least 17 core things that are required for a crew to go build that wall. This list, I've counted at least 50% of it is directly tied to the field engineer, especially the information, the layout, the open space, and the detailed dimensions for components. And also field engineers help the superintendent with those other things that I already mentioned and what's called full kit, because we don't go try and build this until we're ready to finish. This is a beautiful concept. That's from Goldrat's Rules of Flow. So I want you to understand that this is a skill. We must have the information, and we must have the layout, and we must be able to visualize this, and I'm going to draw this in 3D. And if we can, in 4D in time. X, Y, Z, and then T for time is your fourth dimension. So check this out. What we're trying to do is program your brain. I'll mark this brain. What we want to do is build your brain before we build things. This is a concept that I learned in Japan with Paul Akers, which is a lean concept. We build people before we build things. And so what we want to do is program your brain. So if I'm talking to you about layout and control, you're like, Jason, why? If you learn how to do layout and control, you understand and you've programmed your brain how to think in a coordinate geometry system. Jason, why do we do lift drawings? If you do lift drawings, it forces your brain to know how to read drawings and how to visualize in 3D. It's phenomenal. And all of the intersections, interfaces, and how all of the details come together. Well, Jason, why do we go out and work with the craft? Because we're developing a respect for that position so that we can support them. Everything a field engineer does trains their brain, and lift drawings is no different. So I'm going to talk to you about a couple of things here, knowing this with the end in mind, meaning understanding this and considering the end and keeping the end in mind. Let me close out my point in case I'm not doing a good job here. Is that if you have a person in construction management that doesn't see things in 3D, doesn't understand coordinate geometry systems, and doesn't understand plan reading, and doesn't understand how components work together, and doesn't have a love for the craft, that's dangerous. So we have to be committed to building people before we build things. And lift drawings are phenomenal about that, and I don't care if you have self-perform or not. You need field engineers just as much for a non-self-perform job as you do for a self-perform job. That's a myth. I don't know who came up with that, but that's hurting us so badly. You still have concrete folks. They still need layout. You still have masons on the site. You still have overhead and in-wall inspections that you need to do. You still have future superintendents that you need to train. I'm not mad, but I just hate that concept. I'm not mad at people. So first of all, when you're doing lift drawings, you're going to create a lift drawing schedule. So you should be able to pull the activities, hopefully an attack plan, from your project delivery team, from the superintendent. And then what you say to yourself is, okay, when do I need the lift drawing, which usually should tie to the pre-construction meeting, or at least a week before you're going to go do that placement. And then you think to yourself, okay, I need time for the final. I need time for updates, I need time for review, and then I need time to create the lift drawing. So if you have these activities, let's say this is lift drawing 1, then lift drawing 2, then lift drawing 3, then lift drawing 4, you're going to be working in a schedule and in a flow so you don't overburden yourself or your team. So that's step number 1. I'll mark that number 1 up here and number 1 down here. Number 2, I want you to understand the purpose of the lift drawings. There's 3 purposes that are crucial, and I need you to know this. Number 1, the first purpose is to know the building, okay? This trains you as a field engineer to know that component. By the time you're done with that lift drawing, you will know everything in and out. You will be able to inspect rebar. You know that there's dowels coming out of the top. You know there's an embed on the face. You know that there's a sleeve that we need that matches with our 3D model and our BIM coordination. You know that component, and you can go build it with the craft and be a help. So that's number 1. Number 2, and this is huge, find problems. I said in the last video that Scott Berg, the first general superintendent that I ever worked under, said if you can't draw it, you can't build it. And that's absolutely true. And so what he meant was if you can't draw it on paper, if you don't have the dimensions, if you don't have the information, if there's conflicts, if you can't draw it on paper, you can't go and build it because we don't have the information. So it finds problems that you can get answers to before it impacts the work in the field. You want flow in construction? Lift drawings, prefabrication. They will vet that out ahead of time. And then number 3, you have a drawing to build and to double check work. If the carpenters and laborers out in the field and whoever your craft workers are, and it can go for MEP too. You could be doing a lift drawing for an MRI and a bunch of stuff. Whoever the human is, if they're like, I don't need your drawing, you at least have a drawing as a field engineer to double check the work, which if you double check it before you place concrete, before you enclose the wall, before you install it and walk away, that's called quality assurance, quality at the source, not quality control, checking it later and fixing it later. So this drawing is crucial, even if it's just for the field engineer. Number 3, how do we make them? If we have a number of different drawings, we have structural, we have architectural, we have mechanical, we have electrical, we have plumbing, we have vendor-specific equipment drawing. What we do is we take those and we pull the relevant information for one component and one piece flow onto a drawing, and we will follow normal standards. In fact, I'm just going to describe this. I don't have a lot of room to draw it here, but you'll literally draw the plan view, and then you'll do cut sections, and then you'll detail out the sections, and then you'll do an isometric of it, and you'll make sure that you have all of your grid lines, dimension to grid lines, elevation indicators, and then you'll make sure you have a north arrow. Then you'll make sure that your dimensioning is proper and clear. Then you'll make sure that your callouts, your annotations are proper and clear. Then you'll start to do shading. Then you'll clean up the details for printing. Then you'll put them on a sheet. Then you'll actually send them out for review. It's an intense process. Now here's where this gets great. I'm going to put in the description below a link to a beautiful lift drawing review card and other guides for how you build it and what you put into it. But basically, you are going to reference this information and most of the time do a plan view, north arrow with grid lines and appropriate dimensions, and then call outs, and then those will lead to other supplementary information. But the bottom line is then you put it on a title block and you make it according to normal industry standards. So if you would see it on a construction drawings, you would see it here, but ours is a bit more stylish in the formats that I'm used to. Number 4, how do you use it? How you use it is when you get this lift drawing complete, you will want to make sure that it goes through a review, that you update it once that review is done, and then you finish the drawings, review it with the foreman, and when they're out there, let's just draw a wall form. Let's say you've got one wall form and it's on this footing and you've got dowels coming up and you're about to go ahead and install this sleeve, right? You're about to go ahead and install this embed, right? You're about to jam out. You will grab that lift drawing and you'll go out in the field and hopefully build from it, but definitely double check it and make sure that what was built from the drawings gets checked with the lift drawings before you put that second side wall form up, and you place it and you make sure that it's done and locked in and hard and grit. You're going to use that lift drawing to make sure it's right. You can't just give it to somebody and hope for the best. You've got to actually get your butt out there and actually QC that wall and make sure that it's right, and double check, double check the work so that we do not get it wrong. It's not wrong until it's hard and gray or until it's inside that ceiling or inside that wall and you have rework. So how to use it? We make sure that the team has checked it, that the foreman is aligned with it, and that we're using to install and check components in the field. I'm going to turn this into a blog post for you and put it into our new book, Elevating Construction Field Engineers, and also give you the resources for how to make a lift drawing. You're going to love it. I hope you've enjoyed this video. On we go.